In this video, we will be discussing Kubernetes architecture and what is a Kubernetes and why we use it. So we'll be discussing about mostly about the Kubernetes architecture. So coming to Kubernetes, as we all know, we can call it as a orchestration tool. So with the help of the Kubernetes, we can automate the manual process of deployment and manage and run the containerized applications. As we all know, we have a Docker Swarm in place previously, but there is a disadvantage with the Docker Swarm. So where we cannot auto scaling option is not available for the Docker Swarm. So hence, we'll use a Kubernetes, you know, to automate the manual task of deployment and run the containerized applications. So basically, Kubernetes, we have two types of clusters are available. One is a, so let's see this one, self-managed cluster. Second one is cloud managed cluster. So basically we have two types of clusters available in a Kubernetes: self-managed cluster and cloud managed cluster. So self-managed clusters includes, self-managed clusters are Kubedium, Kops, etc. And cloud managed clusters examples are AWS EKS, Azure AKS, Google GKS, and we have a one more IBM Kubernetes as well, but majorly, so these are the cloud managed Kubernetes clusters, and these two are the self-managed clusters. One more we have here, I guess. Third one is a Minikube. Third one is a Minikube. So in this way we can categorize the clusters type in Kubernetes, and let's check it out, that Kubernetes architecture. So wipe it this time. And basically in Kubernetes, for example, here I'm going to explain with the single managed cluster. Okay, where we have a one master. Single managed cluster means one master node and one worker node will be in the same cluster, which is called single managed cluster. Okay, and let me create this is the master node. This is a master node. This is a master node. So basically in master node we have a 4 components, and in worker node we have a 4 components, total 8 components. We can explain if you take the Kubernetes architecture. So I'm just explaining with the a single managed cluster where we have a one master node and one worker node. Okay, and this is the worker node. Master node and worker node. So if you take in master node, the 4 components are API server, etcd, scheduler, controller. So we can call it as a controller manager. These are the 4 components belongs to the master node, and in worker node we have other 4 components, which are kubelet, kubelet, kubeproxy, crt, which is container runtime, we can call it as a docker. Other one, last one is a pod. Okay, these are the four components belong to worker node, and other four components belong to the master node. So let's see uh, about each and every one. So we can call it as a, this is, we can call it as a user. Okay, this is, we can call it as a user. And so let's understand. So when user hit any kubectl command, for example kubectl apply, kubectl parts, or kubectl nodes, what will happen? So as soon as user or operator, we can call it anything, we can find. So as soon as he enter kubectl apply or kubectl get pods, kubectl apply or kubectl get pods, as soon as user or operator enter with any command like this, first of all it will reach out to the API server. So as soon as we enter any type of this command, it will reach out to the API server first. So hence we can call the API server as a gatekeeper. Okay, so we can call the API server as a, we can call the API server as a gatekeeper. Okay, gatekeeper. And as soon as the request will go to the API server, API server will check with the HCD. Okay, so API server will check with the HCD. So let's verify that, you know, responsibility of each and every component first, then we can check the request flow. So API server act as a gatekeeper, and HCD we can call the database of the Kubernetes. So like in one line we can say it is a cluster brain. So whatever the changes that we have done in entire cluster level, those changes will get stored in HCD, which is called a Kubernetes cluster brain. And next, scheduler responsible for scheduler responsible to schedule or choose a node to put the right pod. Scheduler is responsible to schedule or choose a correct node to put the right pod. So whenever these situations occurs where we need to create a pod in suitable node, then scheduler will come into the picture, and will choose the right node. On what basis? So scheduler will choose the right node on basis of size, memory, and CPU. So and scheduler itself, it has own algorithms. Using that algorithms, and based on size, CPU, and memory of the nodes, and it will choose the node and will put the uh, right pod in the right node. This is the responsibility of the scheduler. And next, controller manager. So controller manager responsible to maintain the desired state of any pod, to maintain the desired state of any pod. For example, suppose let's assume that we have a X node. In X node we have a 5 pods, and unfortunately one pod is down. So that controller manager will take the responsibility to make the desired state, which is a 5 before. So this is the responsibility of the controller manager. These are the master node components. And next, worker node components. Worker node components, kubelet. Kubelet. Kubelet will contain the, this is called, we can as a primary component of the worker node. So kubelet will have the all the nodes information. Suppose if any node goes down, then it will inform that, control manager, and control manager will set it back that particular node and make it as a desired state always. So this is what kubelet will do. So basically it contains the all the node information, like we can call it as a node agent. Kubelet will connect the master node and worker node, so that we can call it as a node agent. And primary component of worker node, kube proxy. Kube proxy contains kube proxy responsible for network information. Network kube proxy responsible for network related. Queue proxy is responsible for network related. Suppose services, cluster level IPs, services, and deployments, and all those will be taken care by the queue proxy. So where we can say in one line, so network related information we can find in queue proxy. And other one is a container runtime. So here we are using the Docker. So there are other containers also available like a Rocket. So but in here we are using the Docker CRT container runtime. Container runtime. Next we have a pod. So pod is a wrapper on top of container. So a pod can have a number of containers. Okay, so one container, it can be multiple containers. These are the details about the 8 components in Kubernetes cluster. So these are the roles and responsibilities of each component. Okay, and suppose let's see a workflow. So as soon as user enter kubectl apply or kubectl get nodes, then what will happen? So first first request will go to the API server. API server, it will go to the etcd. So API server is the only one component which will deals with the etcd only. No other component will have a contact with the etcd. So hence API server we can call it as a gatekeeper. So as soon as any request comes from the operator to create pods or nodes, that particular will request go to etcd through API. So etcd will find out so whether that information it has or not. So then etcd reply back to API saying that, hey man, so I don't have any information what you have given, so you can take care of your side. So then API server will check with the scheduler. So what scheduler will do? So with the scheduler itself, it have its own algorithms are based on the size and memory and node CPU. So it will choose the right node to put the right part. This is what scheduler will do. And scheduler will go, and again scheduler will update the info to API server. Scheduler will update the info to API server saying that this is what I found and you can take care of yourself. Then API server will check with the API server will check with the kubelet. So kubelet, hey kubelet, so this is what I have. So I have contacted scheduler. Scheduler given me this node details, and you can go and create the parts. And kubelet, kubelet, and here what will happen? Kubelet will check with the container runtime, because container runtime we are using the Docker here. So but most of the people use the Docker. Kubelet will check with the container runtime. So as we know, containers, we don't deal with the containers Kubernetes, so we'll deal with only parts. So kubelet will create the pods. So pods is nothing but wrapper on top of the container. This is what it does. So pods are nothing but wrapper on top of the container. So pods can have n number of the containers, so that once pod has been created once pod has been created, then kubelet update this information to the API server. Then API server will choose this and give back to the etcd to store the updated information. So whenever any operator or user hits like kubectl get nodes or kubectl pods or kubectl apply, so this is what happened from the backend. So API server will check with etcd will check it out whether that information or not. Then it will get back to the API will get back to the scheduler based on the algorithms it has, uh, based on the size of node, CPU and memory details, and it will find out the suitable or correct node to put the correct part. Once it is done, then it will go back to the API then again check with the kubelet will check with the crt is a container runtime, and as we don't deal with the containers in Kubernetes, and kubelet will create the pods is a wrapper on top of the container. Once pods has been created, then kubelet will inform to the API. So then again API will reach out to the etcd to store the updated information. This is what will happen from the backend as soon as he hit this particular command. So, and one important thing is all the execution will be done in worker node only. So no execution will be done in master node. So this is what we can say if anyone asks us what is a Kubernetes architecture. Thank you.